So, hello everyone, my name is Nirinjimana Bernard. I am IoT and Embedded System Engineer. Today, I'm going to show you how to create a PCB step by step and how to generate bill of materials and how to generate a Giber file and how to load our PCB. So, my task is this. Create a PCB in 3D having weapons and storage on the top layer and your registration number on the bottom layer. B. Create a PCB in 2D. Mount the component on the design the PCB. Record all steps involved in the PCB development and produce the Giber file and bill of materials. So let's start on how to open EasyEda and how to draw the schematic and how to convert schematic to PCB and how to generate all steps as I said above. So let's go to the browsers. Firstly, go to EasyEda, click on EasyEda.com. After clicking, go to profile, click on EasyEda design, go to standard edition, click on it. After, make a new project, go to new standard project, then name it your project, which is called practical cuts, then save. This is a workspace I'm going to use. First of all, go to a company, then rename it, put RP Sons College. After this, hit enter, then rename the sheet, which is called cuts embedded system. Then hit enter. So let me jump to our components. Firstly, we have 1 part, 2 parts, 3 parts, 4 parts, 5 parts, 6 parts, and last part 7. Go. So we are going to start with these parts. Firstly, I am going to connect all pins for this battery, for this capacitor, for this ground or reds, and click on pin ground, connect to this and this, and this, and this, this, connect pin 3 of DCA to the ground. After this, connect pin 2 battery. Connect pin 1 of battery to pin 1 of DC8. After this, connect the pin 1 of DC8 to this diode. After this, connect this pin of diode to this, and this to this, and this to this pin. This, 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 to 12 voltage, and this to this. This connect to here. Connect this Z to this capacitor. Connect this capacitor to 5 voltage. Connect green red to this capacitor. Connect this capacitor to this rod. Connect this capacitor to this rod and connect this to this capacitor. Connect to this capacitor to 12 voltage. After this, we are going to connect this capacitor to this, 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 this capacitor. After this, connect this resistor to 5 voltage. pin 3 of ground, do this. First part is completed. Now we are going to connect this Raspberry Pi GPU extension board. First we connect ground to this pin. To connect CDA to pin, this pin, connect CA to this. Connect this ground to this pin. Connect GMPX to this pin. Connect GMTX to this pin. Connect GMLA to this pin. Connect browser to this. Connect relay to this, and connect road to this. After this, connect this ground to this pin, then connect this pin to this, and connect this pin to 5 voltage. Then after, I'm going to connect part 3. So pin 2 to this probe, connect to this capacitor. Connect this capacitor to 5 voltage. Connect pin 1 of probe to this. After this, connect this pin to 5 voltage. Connect this pin to this resistor. After this, connect this resistor to here, then connect this to ground. After this, connect ground to pin 1 of this. After this, connect back to this pin. After disconnecting this to ground. After connecting to ground, pin here, connecting pin 8 to this capacitor, and this connect to 5 voltage, then connect pin 9 to this CDA to pin 1 of already. After this, connect this capacitor, connect CDA to pin 2 of already, connect this capacitor to already, connect this to pin 1. After this, connect this 5 voltage to pin 3. Disconnect the ground to 4 pins. Then we are going to jump to part 4. So we are going to connect this resistor and connect this pin here and connect this to this, and after connecting this, this to connect to the VCC. After connecting the VCC, connect this pin to reset. After connecting, reset, connect GMLX to this pin. Then connect GMTX to TX. Then after, go to other parts, connect buzzer to resistor, connect resistor to diodes. Connect this diode to capacitor. Connect this to this. After this, connect ground to this. Then after, connect this capacitor to this. After connecting this to this to this, after this, connect this to pin 1 of buzzer. Connect pin 2 this. This we go to other parts. Connect this relay to capacitor. Connect this capacitor to MOSFET pin 1. Connect pin 4 of MOSFET to this diode. After this, connect this diode to battery of 12 voltage. After this, connect this to pin 1 of bipolar MOSFETs, photoresistor. After this, connect pin 2 to pin 1 of the rod. After connect pin 3 to pin 3 of the rod. Connect pin 5 of MOSFET to pin 2 of rod. After this, connect this pin to this. After this, connect this pin to this capacitor and connect this capacitor to this, and then after this connect this to MOSFET, then connect this to this resistor. After, we are going to put ground between this to make to produce a source of power to this board. So go to design manager, go to author, go to library, search grounds. Take a few minutes, so let's use other way. Select this ground and copy that, paste it here. After, go to wire and connect it to MOSFET. After this, connect it to these capacitors. After this, example to other parts. Start connecting. So connect the voltage to this capacitor and connect this capacitor to this diode. Connect this diode to this BC and connect this base to ground. To connecting to this ground, connect this, this, connect VBT to this, this, 5 voltage to VCC. After, connect CDA to and 5. Connect CC8 to CC8, connect CDA to CDA. After this, connect pin 7 to ground. This connect ground. To ground. To connect pin 6 to pin 3. Connect pin 2 to pin 2. Pin 1 to pin 1. To this, connect pin 8 to pin 1. Pin 7 to pin 2. Pin 6 to pin 3 to connect pin 2. Pin voltage connect to pin 8. So after connecting my schematic circuit, first every change you can make, also remember to save. So after saving, I'm going to convert schematic to PCB. So to make this step, can go to design and convert schematic to PCB. Then you can get a warning. There are some unfinished net. Do you want to check the net first? I can choose no, keep going. It takes a few minutes to convert this schematic to PCB. After converting, we'll get a PCB workspace. Firstly, this board you can measure it in two options. Unit 1 is this, and other option is millisecond. Let me choose then copper layer 2. Board outline, you can choose shape as you want. We have rectangular, circular, round, rectangular. The customer, let me choose rectangular, then click apply. I can see anything because my workspace is zoom in. Let me zoom out. As you see, I have all components. I'm going to select all components. After selecting this component, drag into my board. After dragging, can adjust or size my board in the way of arrange my component to fit into our boards. Then resize it. After this, I'm going to make a top layer as Arapin sounds correct. Click on top layer. After click on top layer, go to T as text and drag down to my PCB board. Let me zoom in to see what's happening. After click on text, then write RP sounds courage. Click enter. After creating a top layer, we are going to create a bottom layer. Let's click on bottom layer and click on text. Click on this text, then write my registration number, which is called 25 RP 18795, then click enter. After let me check my PCB board in 2D. Good. Let me check my PCB board on it is better to resize our PCB well arranged. Good. After well organized, let's check our PCB in 3D. Let's click on 3D. Take a few time. This is what we call my PCB. This is our component. Then I want to show top layers, RPM Sanji Courage. On bottom layer, let me check. This is what we call my leg numbers. After this, we are going to make a lot. I'm going to click on routes. After clicking on routes, choose real-time display and choose crowd. After choosing crowd, click run. Oh sorry, board outline are not closed. Let me check issue. I think is available here. Good. Let me let's do this again. Okay. Try. Let me zoom out. components. Put it here and top layer. Sans courage. Bottom layer. Five RP 18795 out check to D. Good. After checking 2D, let's check 3D. Good. Let me check bottom layer 25 LP 18795. Check top layer RPM Sans Courage. Good. After I am going to make a wall to my PCB. Choose board, then click on here and here and here and here. After, let me check 2D again. Good. Let me check 3D. Good. My PCB, make it off. Good. After that, I am going to make a route. Go to route, then choose your term display, choose crowd, then run. After running, wait a few moments to create routes one by one. Good. Good, my route is completed. After you see route is created, so let me check 2D again. This is route channel. Let me check on 3D how it look like. Good. Wait a network. You make a save. After saving successfully, let me check 3D. There is a network issue, but our route is already created successful. So as you see, this is my component variable one by one because of a network. So now we are going to generate bill of materials and Giber files. So going to my schematic, then go to fabrication, click on BOM. After click on BOM, import, export BOM, then select all components and export BOM. After exporting BOM, go to downloads, then click on BOM, which is called RP Sans College Cards Practical, then open it in Excel. We have BOM, which is have ID name, design, footprint, quantity, manufactured, port, manufactured, supply port, price, pin, contributor, GAC, PCB, pre-port, cross, parts, type, image, and the link. After exporting the BOM, I'm going to generate Giber files. So can go on fabrication. Firstly, go to PCB, then go to fabrication, move down, click on PCB fabrication file Giber, click on it, click on no generate Giber files, then click on generate Giber. After generating Giber file, can go on downloads, our Giber file generated successful. So this is the end of our task. Thank you for your attention. See you on next activity.